Hello everyone, this is Jayanthi Prathyusha, a research scholar from Indian Institute of Technology Bombay working under the supervision of Professor DNC. As a part of great project, I have done my secondments from University of Strathclyde under the supervision of Professor Alessandro Tarantino. I have worked on the topic determination of osmotic suction of marine clays using filter paper technique. To start with, suction is the energy with which water is held within the pores. It finds its applications in slopes, barriers of waste containment facility, top covers or liners of landfills, dams, and embankments. It can be expressed in terms of soil water characteristic curve or in general water retention curve, which is a function of suction and moisture content. It is constituted of matrix suction and osmotic suction, where matrix suction is due to the capillary action that is generated during the removal of moisture under pressure or under evaporation circumstances, while osmotic suction is due to the salt or ionic concentration. Hence, osmotic suction prevails only in saline or marine soils or chemically contaminated soils. Many techniques exist in literature to measure the suction. For total suction, psychrometers, filter papers, or dew point potentiometers can be used, while for matrix suction, tensiometers, filter papers, pressure membrane extractor, or axis translation technique can be used. Whereas osmotic suction cannot be measurable using any instrument and hence has been quantified as difference of total and matrix suctions by many researchers. However, the existing techniques either cannot reach the higher range of suction or will not be applicable for saline soils. Hence, an objective has been set to quantify osmotic suction using filter paper method in order to achieve higher range of suctions and measure directly on saline soils. The materials considered for this study include commercially available wire clay or kaolin, which is used for the calibration of filter paper, and naturally occurring marine clay collected from west coast of India for determining the osmotic suction. The instrumentation or methodology employed includes the Wattman 42 filter paper, tensiometers for calibration of filter paper, and WP4C dew point potentiometer for measurement of total suction. In order to calibrate the filter paper, a slurry of white clay is taken and consolidated in an odometer at 100 kPa pressure to achieve a moisture content which is uniformly distributed. Further, it has been dried at ambient condition to reach a target of desired moisture content. Later, it has been placed in a metal chamber which is insulated against evaporation with a filter paper at the bottom which is sandwiched between two other filter papers to maintain it in contact with the sample and in order to calibrate against the matrix suction, while a filter paper placed on the top which is separated by a mesh is used to calibrate the not in contact filter paper. Tensiometer has been used as a calibration device for the matrix suction which is placed in contact from the top on the sample. The data has been recorded for matrix suction until it reached equilibrium for the tensiometer values, and later the filter papers which are in contact and not in contact are placed in oven to achieve to get the moisture content of the filter papers, and a sample extracted from the dried sample is placed in WP4C to get the moisture content to get the total suction of the sample at that given moisture content. The experimental procedure has been repeated on white clay prepared at different moisture contents, and the matrix suction from tensiometer and water content of filter paper have been used to determine the calibration curve of in-contact filter paper. This data has been further validated using the ASTM standard curve and the already existing water retention curve data of the white clay. This method proves that tensiometer is a good tool to determine the calibration curve of in-contact filter paper which measures the matrix suction. Similar procedure has been adopted for filter paper not in contact, which has been calibrated using the WP4C dew point potentiometer. Based on the calibration data of the filter paper, studies have been progressed to obtain the osmotic suction of marine clays as a difference of total suction and matrix suction which is obtained from the filter paper. For this, marine clay sample has been prepared by consolidating its slurry using an odometer at 100 kPa pressure. Further, this sample has been dried at ambient conditions to achieve a desired moisture content and equilibrated for 24 hours. Later, a filter paper sandwiched between two other filter papers is placed at its bottom to measure the matrix suction, while a filter paper separated by a mesh is placed at the top to measure the total suction. The entire setup is placed in an insulated chamber to avoid evaporation for a period of 7 to 10 days so as to attain equilibrium of the filter paper with that of the sample. Later, the filter papers have been weighed and placed in oven to obtain their moisture content, and based on this moisture content, the calibration curve. The total and matrix suction values determined from the filter paper calibration data have been represented as a function of water content and suction, and the difference between these two gives the osmotic suction. The second figure indicates that osmotic suction has a major contribution in deciding the response of marine clays, and it contributes a major portion of the total suction when compared to that of the matrix suction. To conclude, calibration of filter paper in contact can be achieved using a tensiometer, which is entirely a different approach. However, a filter paper which is not in contact requires a lot of time for equilibration, and hence WP4C potentiometer can be used directly to measure the total suction, which is one of the best methods. Filter paper technique can be considered as a better method to determine osmotic suctions of higher ranges. To include in the future scope, validation of the obtained result using other techniques is necessary. Also, the obtained osmotic suction data can be related to the response of marine clay in terms of its tensile strength and water retention capacity during the desiccation. Thank you.